didn't find a need to do this with my pre-calculus classes and calculus classes either. But it's a very good question. What can I do if that's the case? Good. I'm going to choose first then, since you are slow in choosing. 7 natural log x minus 3 natural log y. So in order to condense, I'm using the same 3 properties: product, ratio, and power, nothing else. So first, I have to locate this back, or take it back where it came from. It's the same thing here. Take it back where it came from. Where did it come from? It came from the power of x. And now I know what to do. There is a minus. This has to come from the denominator of the expression. So it will be x to the 7th over y to the 3rd. So I condensed whatever I was given into log with 1 in front as the coefficient, and whatever expression. This is the way we condense. Anyone would like to choose the next one?
63.
63 it is. 1/2 outside, log x plus log y. Very good. Of course, we have to start inside. Can anyone condense the inside for us?
Log x plus y
Careful.
times y.
Very good. Awesome. And there is a number in front that has to come from the power of the expression. Well, what power is 1/2?
Negative. No, square root.
Is that clear?
Yep.
Good. Anything else to condense? Anyone else? Anyone want to condense anything else? Okay, I want to condense 70. So log x plus log x squared minus 4 minus log 15 minus log x plus 2. If you remember what I did in one step, you will tell me how to write this in one step. They all have the same base. In this class, they all have the same base. Log of what?
X on top times x2 minus 4 over 15 times x, is that x squared? X plus 2.
That's it. Done. However, I realize that this can be factored and I will simplify, but it's done otherwise. Why? The logs with plus in front have their quantities at the top. The logs with minus in front, their quantities have to come from the denominator. So then I have log x and I factor into x minus 2 and x plus 2. The denominator is this. And I will simplify one factor. So the simplified form is x minus 2 over 15. Once you understand the 3 properties and how to apply them, from that moment on is not a big deal, I think. Do we need to practice more, either expanding or condensing? Is that a yes? Is that a no?
I'm good.
Everyone else?
I'm good.
Okay, moving on then. Finally, in 4.3, that's why we learned all this, for exponential, of course, and log equations. And as I tortured you the entire semester already, here it is. Here we are. So we're going to reach everything. This is it. So we know 10 different types of equations, all of these that we knew from before, and now exponential and log. And that's it this semester, nothing else when it comes to equations. Okay, so we start with exponential first. Here is the easiest possible. We already solved one last time. Here's another one, the easiest possible equation. What do you think x would be? Of course. If two numbers are equal and they have the same base, their exponents must be the same. This is the easiest possible exponential equation. Of course, and from here on, they will get more and more complicated. Here is one. Okay, the first one that we looked at obviously had the same base left and right. And that's what I'm looking for. If possible, no guarantee. So I'm looking at 1/8 and I'm looking at 4 and I'm asking myself, can I present both with the same base? And the answer is yes. If I remember that 1/8 is basically 2 to -3, and I remember that 4 is basically 2 squared, then I make my life so much easier than there is another way, of course, but I make my life easier. If I change this into 2 to -3, copying everything else to the t, replace 4 by 2 squared, copying everything else as is. Now, this will very fast reduce to this. But I needed work to reduce it to that. Now I have to copy the base. What do we do with these exponents? Which operation we perform with -3 and 2x minus 1?
Don't you multiply them?
Excellent, thank you. -6x plus 3, great job. 2. -3 times 2x, -3 times -1. So 2 raised 2, the same property, 2x plus 8. Yes, I needed work, but now it reduces to this. Two numbers are equal and they have the same base. What has to happen to their exponents? And there is no other way. They must be
To be equal.
excellent. -6x plus 3 must equal 2x plus 8. I know how to solve this. I move 2x and I move 3. When I move 2x, I get -8x. When I move 3, I get 5. So the answer is -5/8. And I know you're going to ask, fine, you were able to present both sides with the same base, but what if it doesn't work? Yes, we have a cure for that too. But I would like us to choose some more problems before I show you that, that method. We are on page 500 and 500 and sorry. 514. Thank you for your patience. Okay. So you can choose anything you want from 1 through 22, and then later on from 23 to 48. But we're not ready for these yet. In a minute. So please choose anything you'd like from 1 through 22. If not, I will. 1, yes, which one?
16.
16, very good. In 16 we have 7, I think it's raised to x minus 2 over 6, let me know. Equals the square root of 7. Very good pick. I see that both sides can be presented with the same base. There is nothing I can do here. This is done. But I do remember that this is 7 raised to which power?
1/2.
Thank you very much. So then the equation is 7 raised to x minus 2 over 6 equals 7 to 1/2. Nice. Two numbers are equal and they have the same base. What has to happen? Otherwise, they will not be the same.
They have to be equal, so x is 5.
X minus 2 over 6 must equal 1 over 2. And we cross multiply. 2x minus 4 equals 6. So you're right. 2x equals 10. X equals 5. Excellent. I love it when my students are way ahead of me. Less work for me. I'm kidding. I don't want less work. I want to help you navigate this. Okay, do we need other examples from 1 through 22? 22 caught my eye, unless you have something else on your mind.
No, I like 22.
22, I think it's e to x plus 4 equals 1 over e to 2x. Can I write both sides with the same base? Yes. If I remember that the right-hand side can be written as e to which power? E to negative 2x. E to negative 2x is the same with 1 over e to 2x. A to negative n is 1 over a to the nth power. Agreed?
Agreed.
Perfect. What do I do now? Two numbers are equal and they have the same base. What has to happen?
You have to set the exponents equal to each other.
X plus 4 equals negative 2x. Let's say I move x to the other side, I get negative 3x. So x equals negative 4 over 3. Now the next set of 23 to 48 requires more work. Simply because the two bases will not be the same and we cannot make them the same. But we have a cure for that too. Anyone would like to choose? Don't choose from 43 through 48 first, because I like to show the first, what is it, 23 to 42. 41 and 42 are the most difficult. So let's start with 23 through 40, and then we'll do 41, 42, and some from 43 to 48. So the first, we should choose from 23 through 40. And then we will look at 41, or if you want 42, it doesn't matter to me, and then 43 through 48.
We do 33.
33 it is. Okay, so e2, 1 minus, I think it's 5x, correct me if I'm wrong. I think it's 5x. Okay.
Yeah, it's 5x.
There is no way I can present the left-hand side with e and the right-hand side with e. It doesn't work. So, do you remember what we did when we solved the equation, the square root of x equals 2? What did we do to both sides?
We squared them.
Right. We squared. Why? Because squaring and taking the square root are inverses of each other, inverse operations. And the square will eliminate the square root and we get x. And on the other side, 4. What is the inverse function of e to the x? That's the function I have to apply to both sides. So here I had the square root, I apply the inverse function. If I have the cube root, I apply the inverse function. Now I have base e. What did we say?
Isn't it ln?
Exactly. Thank you. We apply natural log to both sides, like applying square root, like applying power 2 to both sides, or applying power 3 to both sides, or taking the square root from both sides. We're applying this function to both sides because it's the inverse of the exponential. And why? Here's why. 1 minus 5x becomes a factor. Now I have natural log e, and the other side is natural log 793. But how much is natural log e?
1.
Exactly. So then we have 1 minus 5x equals natural log of 793. It's not done, but I want to say one thing. Please do not ever be afraid of this number. It's just a number. It's a composition of an operator or a function and a number, but it's still a number. Don't get bothered by it. It's just a number. I still have to subtract 1 and divide by -5. So negative 5x equals natural log of 793 minus 1, and I divide both sides by -5. And this is it. Can I approximate it? Yes. So then x equals negative 1/5 natural log of 793 and plus 1 over 5. If you want to approximate, yes, we can. You may say, I want to approximate because I want to check my answer. Fine. So be careful how you put this in. I would recommend it put it in parentheses. Parenthesis negative 1 divided by 5 and close the parenthesis. And then put natural log of 793, close the parenthesis, and then plus 1 divided by 5. And press enter. So I got approximately negative 1.13516. And now you can say, show me that this works. Fine, I will. So I will take E. No, that's not E. I will take E, put parentheses, 1 minus 5 multiplied by, I will not delete the answer, second and previous answer. And when I press enter, if I don't get 793, something is terribly wrong. If you truncate the number, and if you just write this, 1 minus 5 multiplied by 1.1, let's say, I'm not going to get 793. I'm going to get very close. What did I do? Negative 5 times E. I'm telling you, this calculator, and this is not the first time. There is no mistake.
Did you forget the negative?
No. Oh, I did forget the negative. Thank you. I did forget the negative. Thank you very much. So it's positive. Yeah. However, I did find at times, thank you so much for noticing that. I did find at times that something is not, I'm not sure. There are some glitches every now and then, but it could be my error, as it was this time. So if you recall the entire answer, you'll get exactly, but if you just truncate the number into negative 1.1, like I did, and not use more decimals, I'm away from 793. Good, very good. Thank you.